There is a black hole sitting at the edge of the observable universe that should not exist. It weighs 1.6 billion times as much as our Sun, and we are seeing it as it was when the universe was only about 670 million years old, barely 5% of its current age. A monster, fully grown, at the dawn of everything. Here's the problem. Black holes don't appear at their final size. They have to grow by swallowing matter, and there is a hard physical speed limit on how fast they can eat. Run that growth backward, as fast as the laws of physics allow, and you hit a wall. To be this big, this early, this black hole would have needed to start as a seed of at least 10,000 suns. And nothing in our standard picture of the cosmos knows how to make a seed that heavy. So either our understanding of how black holes are born is incomplete, or something happened in the infant universe that we have never seen and still cannot explain. This is the story of the black holes that were born too big, and of one object, found in 2023, that may be the closest we've ever come to catching the impossible in the act. To understand why astronomers were so shaken, you first have to understand what they were looking at. The object is called a quasar. A quasar is the brightest sustained thing in the entire universe. At the heart of it is a supermassive black hole, feeding so violently that the gas spiraling toward it heats up and blazes, outshining every star in its host galaxy combined. A single feeding black hole, brighter than 100 billion suns. That brilliance is the only reason we can see them at all across such enormous distances. Their light has traveled for more than 13 billion years to reach us. When you look at a quasar this far away, you are not looking across space. You are looking back in time, almost to the beginning. Finding the most distant ones is brutal, patient work. Their light gets stretched by the expansion of the universe until it shifts deep into the red and infrared. So astronomers comb through enormous digital surveys of the sky, hunting for a single faint, reddened, hiding among millions of ordinary stars and galaxies. In late 2020, a team led by a young astronomer named Fij Wang was doing exactly that, sifting data from a large sky survey taken with a telescope in Chile. One candidate stood out. They confirmed it was a quasar using the Gemini telescope, then measured its central black hole with the giant Keck telescopes in Hawaii. The object got a catalog name, J0313-1806. And when the distance came back, it was a record. The most distant quasar ever found, seen as it was just 670 million years after the Big Bang. But the record wasn't the part that disturbed them. It was the mass. 1.6 billion solar masses, already assembled, at a moment when the universe had barely begun to make galaxies. The team sat with the arithmetic, and the arithmetic refused to work. So began the investigation. And like every good mystery, every answer they reached for fell apart in their hands. The first and most natural idea was this. The very first stars to ever form were giants, enormous balls of nearly pure hydrogen and helium, far larger than stars today. When they died, they would have collapsed into black holes, ready-made seeds scattered across the young universe, each maybe 100 times the mass of the sun. It's a clean story. Start with one of those seeds, let it feed steadily for a few 100 million years, and surely it grows into a giant. That was the textbook answer. And it doesn't work, because of that speed limit. When a black hole pulls in matter, the matter heats up and shines, and that radiation pushes outward, shoving away the very gas the black hole is trying to swallow. Feed too fast, and you blow your own food away. This ceiling is called the Eddington limit, and it sets the maximum rate at which a black hole can grow. Do the math. Start from a 100 solar mass seed. Feed it at that maximum rate without pausing, and by 670 million years you still fall short, by a wide margin. There simply isn't enough time to climb from a dead star to 1.6 billion suns. The light seed model runs out of clock, so scientists try to rescue it. What if the black hole broke its own speed limit? In short, violent bursts, a black hole might briefly feed faster than the Eddington rate, so-called super-Eddington accretion, gorging beyond what should be possible. Stack up enough of those bursts, and maybe a small seed could sprint to giant size in time. It's a real idea, taken seriously, but it's fragile. Sustaining that kind of runaway feeding is difficult, and as we'll see, for the most extreme objects it simply cannot reproduce what we actually observe. A promising patch, but not a solution. There was a middle path, too. Imagine a cluster of stars so dense that they begin colliding and merging, piling up into a single heavy object that then collapses, an intermediate seed, thousands of suns, heavier than any single star could leave behind. Better, but for J0313-1806, the Discovery team judged even this too small. The black hole was so massive, so early, that the cluster idea couldn't carry it across the finish line either. Every conventional explanation pointed the same direction, towards something heavier at the very start. And that led to the boldest idea of all. What if some black holes never began as stars at all? The proposal is called direct collapse. In the early universe, picture an enormous cloud of pristine gas, and instead of fragmenting into stars, the whole thing collapses, all at once, straight into a single black hole. Not 100 suns, not 10,000, potentially 100,000 solar masses, born in one event. A black hole that skips the stellar stage entirely. A heavy seed, with a colossal head start. On paper, it solves the timing problem in a single stroke. Theorists had predicted it years earlier. But it had a weakness that haunts every elegant idea. No one had ever actually seen one. It was a beautiful explanation in search of evidence. And then, in November of 2023, the evidence walked through the door. NASA announced a new object, found by combining two of the most powerful eyes we have ever built. The James Webb Space Telescope, seeing in infrared, and the Chandra X-ray Observatory, seeing the high-energy glow of matter falling into a black hole. The object is called UHC-1, and it broke the record again, pushing back to a redshift of about 10.1, which places it roughly 470 million years after the Big Bang, even earlier than J0313, even deeper into the dawn. They could only see it because a massive cluster of galaxies sat between us and UHC-1, its gravity bending and magnifying the faint light behind it, a cosmic lens, doing for us what no telescope alone could. Chandra caught the X-ray signature of a feeding black hole, weighing somewhere between 10 and 100 million suns. Large, but on its own, not the shock. The shock was the proportion. In the universe around us today, a galaxy's central black hole is tiny compared to the galaxy itself, about 0.1% of the mass of all its stars. A small dark heart inside a vast body of light. UHC-1 was different. Its black hole was roughly as massive as every star in its entire host galaxy, combined. The heart weighed as much as the whole body. Astronomers had a name waiting for exactly this. An overmassive black hole galaxy. And it matched, in remarkable detail, a theoretical prediction made years before for what a direct collapse seed should look like in its youth. For the first time, here was a strong candidate for a black hole that did not grow big. It was born big, forged whole from collapsing gas, in the first 500 million years of time. You might think a discovery like that would close the case. Instead, it cracked it wide open. Because once the James Webb Telescope began its survey of the early universe, UHC-1 turned out not to be a lonely freak. It was the first hint of a crowd. Webb kept finding them. Black holes in the first billion years that were far too massive for their galaxies, far too numerous, far too developed for that early in cosmic history. A whole population that the old models said should not be there. Among them, a strange new class of objects nicknamed the little red dots, compact, deep red smudges scattered across Webb's images. Many appear to be young supermassive black holes, swaddled in gas and dust, and there are far more of them than anyone predicted. Their exact nature is still fiercely debated. What had been one impossible black hole became a systematic problem. The early universe, it turns out, was building giants with an efficiency we genuinely do not understand. So where does that leave us? What we know for certain is solid and strange. These black holes exist. Their distances and masses are measured. J0313 is real. UHC-1 is real. The population Webb is uncovering is real. And the simplest story, a modest stellar seed growing slowly into a giant, cannot account for the most extreme of them. That much is not in doubt. The leading explanation now is the heavy seed, direct collapse, gas falling straight into a black hole without ever becoming a star. It fits UHC-1 better than anything else. But fits is not the same as confirmed. No one has ever watched a direct collapse seed actually form. It remains an inference, a shape glimpsed through the data, not a thing we have held in our hands. And at the far edge of the debate sit the wilder ideas, raised seriously but unproven, that the seeds were primordial black holes, formed in the Big Bang itself, older than the first star. Possible, not established. An honest maybe. The real answer is that we are standing in front of something genuinely unfinished. We can see the monsters. We can weigh them. We can prove they were there before they had any right to be. What we cannot yet say is how the universe made them so quickly, so completely, so soon. Every telescope we point at the early cosmos brings the problem into sharper focus without solving it. The black holes were already waiting at the dawn, fully grown, impossibly heavy, sitting in the dark before the first galaxies had finished taking shape. Something built them in a hurry, at the very beginning of time, and then left no instructions behind. We are still reading the universe's first chapter, and the giants were already on the page before the story should have started. Subscribe, and let's keep tracing them back, all the way to the seed that shouldn't exist.